This is a video looking at Gauss problem 10, year 2020. So let's just put a quick title. So we've got Gauss problem 10, 2020. Okay, so problem 10 asks us to find the last two digits of a sum of powers. So we're asked to find the last two digits of 3 to the 1, 2, 3 plus 7 to the 1, 2, 3 plus 9 to the 1, 2, 3. Okay, so we need an arithmetic which finds the remainder of this sum when divided by 100 because it's the last two digits. So last two digits Okay, so let's just rewind for a second and let's have a look at the last digit and last two digits. Okay, so let's get some numbers. Let's get 12, 1, 2, 3, 1, 2, 3, 5, 6, 7, 8, 9, 4. Okay, we can see that the last digit here is 10, 3, 5, and 4. And to get the last digit, we divide by 10. We get 1. Remainder is equal to 2. Divide by 10. We get 12. Remainder 3. Divide by 10. We get 1, 2, 3. Remainder 5. And here we get, divide this by 12. We get 6, 7, 8, 9. Remainder 4. Okay, so we need an arithmetic which gives us the remainder of a number on division by 10. So I'm just going to let you think about that. And if you completed the Gauss book, you should be able to answer that question. So let's have a look at the last two digits. So let's just do 3 examples. Let's do 1, 2, 3. Let's do 1, 2, 3, 4. 1, 2, 3, 4, 5. So you can all see that the last digit there is 3, 4, and 5. And to get the last digit there, we simply divide by 100, divide by 100, divide by 100. If we divide by 100, there we get 1, remainder 23. If we divide by 100 there, we get 1, 2, remainder 34. If we divide by 100 there, we get 1, 2, 3, remainder 45. Okay, last two digits up in the last one digit. Okay, I'm hoping now that you can recognize that the arithmetic we use to find the last digit is mod 10, and the arithmetic we use here is mod 100. Okay, marvelous. So just pause the video and see if you can understand what we've done, and then we'll move on. Okay, so hopefully you've done that now, and you're familiar with the fact that to find the last digit, we use mod 10, and to find the last two digits, we use mod 100. So let's have a look at some examples for powers. Let's get rid of this. Okay, so we are ready to find the last digit and the last two digits. Okay, so let's choose quite a difficult example for the last digit. So find the last digit of 11797 to the power of, let's try 2014. Okay, so we need to find what this is equal to mod 10. So we need to find the division of this and the remainder when divided by 10. So let's do that then. Let's convert this number to mod 10. So how many 10s go into this number? So we've got 1179 multiplied by 10, and then we need to add on 7. And it's all to the power of 2014 is congruent to a mod 10. Okay, now I'm hoping you can recognize that this is simply 0 in mod 10. So we have 7 now to the 2014 is congruent to a mod 10. So we now need to look at values of the powers of 7 and stop when we get to a remainder of 1. So let's have a go doing this then. I'm going to do this in a different color. Let's try blue. So I think everybody can be confident that at 2. So 2 squared is 49. This doesn't help us. 7 cubed is 343. That does not help us. 7 to the 4 gives us 2401. Okay, so in mod 10, 7 to the 4 is 1. So let's see if we can reduce this. So we've got 7 to the 4 multiplied. Okay, so let's do 2014 divided by 4. That gives 503. Then we need to add on a 2. Congruent to a mod 10. Okay, so let me just explain the power there. If we multiply 503 by 4, we get 2012, which is the same as 7 to the 4. And we've established that 7 to the 4 is 1 mod 10. And then we need to add on a 2 or a 7 squared to get back to 2014. Okay, so let's use our rules of indices then. If we've got, let me do this in red. If we've got a to the xy, that is the same as a to the x multiplied by a to the y. Okay, by rules of indices. So let's do that then. So we got 7 to the 4 times 503 multiplied by 7 squared is congruent to a mod 10. Okay, I think we can all recognize now this is 1 from this here. So we're simply left with 1 multiplied by 7 squared is congruent to a mod 10. Well, 7 squared is 49 is equal to a mod 10. And we're asked for the last digit, therefore last digit is 9. Okay, so let's look at the last 2 digits. So pause the video and see if you can understand that. This is quite a powerful concept here, that we just look at values of powers of 7 until we get to 1. That means that the mod of that number, if we're in the tens, is 1. Let's do another example just to illustrate that. Say, for instance, we're dealing in, I don't know, let's do powers of, so we're doing last 2 digits. So let's do powers of 7 again. Let's do powers of 7 again, and we want to find what 1 is worth mod 100. So we got 7 to the 3 is 343, and we got 7 to the 4, which is 2401. Okay, so mod 100, we need 01. So we know that 7 to the 4 is congruent to 1 mod 100. And we can show that because 2401 divided by 100 is 24, and we've got a remainder of 1. 24 multiplied by 100 is 2400, and we have a remainder of 1. Okay, so I'm going to keep that up on the screen, and I want you to pause the video and I want you to find the last 2 digits of 7 to the, let's do 2019. Okay, so pause the video and see if you can find this. Okay, so hopefully you've done that now. And we needed our value of A mod 100. So we've already done the hard work here, because we know that 7 to the 4 is congruent to 1. So let's multiply that 4 by 504, and then we need to add on 3. So let's just check that. Okay, so we got 2019 divided by 100. Okay, not divided by 100. We got 2019 divided by 4 rather gives 504. 504 multiplied by 4 is 2016, 17, 18, 19. We need to add on 3. Okay, getting very close to the answer. So by rules of indices, we can write this: 7 times 504 times 7 to the 3 A mod 100. So that just gives 1 times 7 to the 3 is equal to A mod 100, We know that 7 to the 3 is 343 mod 100. If we divide this by 100, we're going to get a remainder of 43. So the last two digits are 43. So let's do a recap. So in order to find the last digit of a number, didn't want to do that, we use the mod x arithmetic and let's find last digit mod x value. So you can pause the video and try and work out these values. So to find the last digit, last two digits, last three digits, last four digits, and the last 5 digits. So pause the video and tell me which mod we're going to be working in. Okay, so hopefully you've done that now. I'm going to do this in red. So to find the last digit, we're working in mod 10, mod 100, mod 1000, mod 10,000, then mod 100,000. And hopefully you can recognize here that we got mod 10 to the 1, mod 10 to the 2, mod 10 to the 3, mod 10 to the 4, then mod 10 to the 5. Okay, so hopefully you're confident in finding the last digits of large powers. If you're really interested in this topic, there's another really nice topic in modular arithmetic of finding the inverse of values given a particular mod. And I'll be doing a video on that soon. Okay, keep up with the maths and well done for watching the video.